All right, everyone. Good evening. Welcome to the VanQ meetup. It is Thursday, April 29th, 2021. Hope you're all doing well, keeping safe, keeping healthy. We're really excited to welcome Sean Wilson to be our speaker this evening. Sean started as a manual tester on a financial treasury application somewhere in the last millennium. His career took him on a winding journey through automated testing, development, project management, and agile evangelism before he abandoned all that mainstream software and went where he could play games and get paid for it. In his current role as a worldwide QA/QC development director for Ubisoft, Sean is focused on evolving the approach to quality assurance through a better application of technology. We're really excited to have him back. I'll pass it on to Sean. Just a heads up, there will be opportunities to ask questions, and Sean will let you know when those times are. So take it away, Sean.
Thank you very much, sir. Hello to everybody in Vancouver, or presumably somewhere in Vancouver, because really, who knows? I am calling in from Montreal tonight because my job is taking me out here. So it's interesting and fun to be able to speak English, which is good because I don't really speak French. Okay. Tonight, we're going to talk about data-driven test automation frameworks. This is something that's funny. Throughout my career, I've been using data-driven testing approaches. I've been using test automation frameworks, so I built them. And just recently, we've gotten the chance to start doing that at Ubisoft. And it's been quite exciting, some of the things we're doing. So we're going to talk about how we're generating and executing automated tests directly from game data, which is kind of interesting. So why are we here? I believe firmly that we should always know what we want to get out of a presentation. Otherwise, we don't know if we had fun. So the goals for the presentation are pretty light. I want to provide a bit of an overview of both the data-driven testing approach and the concept of a test automation framework. I want to show how we can and are starting to actually use data-driven test automation frameworks at Ubisoft right now. And I want to talk through some of the ramifications and benefits of what we found as we go through the POC. Okay, so our high level concept, and at its most basic level, this is what we're planning to do. So we're going to use automation to figure out what we can test. We're going to create automated tests dynamically. We're going to test the things that we can test and run all the automation that we can. Sounds simple, right? And I know it sounds a bit like the start of Skynet, but it isn't that bad. We're not generating a complete AI system for this. We're really just combining the common software approach of data-driven testing with a test automation framework. And this is something that has been done before. Okay, a couple definitions to get out of the way. I'm going to put them up and talk over them anyway. But just so that we're on the same page, there's a ton of information about both of these topics. You can find it online. I'm including a couple of links from Wikipedia, and we will talk a little bit more about them in just a couple slides. So the first definition is for data-driven testing. The key takeaway here is that data-driven testing is a common software test approach, where for any given defined test, you can use a table of inputs and expected results as the test parameters. So effectively, for this test, these inputs should receive those results. Right, and I think that it sounds complicated maybe, but it's just as simple as that. So a test automation framework, our second definition, the key takeaway here is that a test automation framework is not specific to a single test. So rather it's a structure that enables automated tests for a product or a feature area, or in our case, we'll be using different features across multiple products, but that's all to come. So with a good framework in place as well, automated tests are easier to build, maintain, and execute. And that's really sort of the key takeaways for test automation frameworks. So let's jump into it. And we'll talk about a data-driven testing first. So in the definitions, I said that the key takeaways for data-driven testing were that if you've got a defined test, you can have test parameters come from a table of inputs and expected results. So our test definition has to contain the logic. And this is all the stuff that goes into how the test is constructed and run. So anything from where and how to connect, the actual test steps, the logic, or the business rules need to be followed in order for us to do the test or generate the data. And if you take a look at this simple sign up page, I'm clearly not a designer, by the way, you can sort of guess where those test steps are, right? Enter an email address, enter your password once, re-enter it, click submit. Those are the steps that any tester would do to sort of go through this functional part of the application. When we talk about the data, the first thing we have to do is define the format that will conform to the test logic. So in this case, we need some sort of identifier, test case 1, 2, 3, 4, 5. We need to know the usernames to enter, the passwords, and whatever result we expect. Let's take a look at that. For test case 1, for example, if we enter in this email address, the 2 passwords that you see and click submit, we should get a pass. That's it, right? And yes, I'm hand waving a little bit over the details here. I'm not giving you the business or data rules that tell you why that password or this information, that line of data leads to a pass or a fail. I think you can get where I'm going sort of in this approach though. To be comprehensive, even for a simple case like this, the data set could be exceptionally large. Really depends on how complex your business rules are about passwords or email addresses. And if you go through a slightly more complicated test, the number of actual test steps or test parameters is massive. The problem is that manual testers skip steps. It's hard to get a manual tester to run effectively the same 99, 100 tests in a row, exactly the same way, every day, every build. And I think that's one of the challenges that data-driven testing sort of helps us with. It identifies exactly what we have to do, but it really gives us that you must do exactly this thing. So all of this together gives you 2 complete distinct sets of information. The test definition or the logic, and the input and result information or the data. With this information, really anybody should be able to do the test and to understand, to some degree at least, how this feature of the application works. So before I go on, that's data-driven testing in a nutshell. Are there any questions about that before I jump into a test automation framework? If not, I will jump ahead. Perfect. Okay. So let's look at a test automation framework. In the definitions, I said that the key takeaways for a test automation framework are that it's not specific to a single test, and that with a good framework in place, automation is easier to build, maintain, and execute. Since our focus for tonight isn't on sort of what the test automation framework is, but really how we can actually use one, I don't need to dive into all the details, but it is important to understand sort of the core steps or nodes of a test automation framework. So these stages are going to be input, generate, execute, and report. For this presentation, again, I'm going to focus primarily on input and generate. There is complexity and some interesting stuff that can come out of execute and report layers as well, and I will touch a little bit on it. But I think those are easier to understand conceptually, so I don't want to spend as much time on them. If you have automated tests, run them. If you run automated tests, look at the results. Right? They kind of make sense that way. So let's take a little bit of a closer look at input. So input takes the format used to show pass or fail conditions, and then either test case data or the logic required to generate or gather the test case data. From these, we create the full list of automated test conditions, which are very commonly referred to as test permutations. So if you consider the data file from the last test example, that output of all that file is kind of each one of those is a single permutation. So the generate stage is where we're going to create the test suite and the script files. So at this point in the test automation framework, I am doing a little bit of a hand waving. And this is really about the feature hook mapping. I'm making an assumption that if you are starting to use a data-driven test automation framework, you have an application that is automatable. If you can't automate it, adding a framework isn't going to help you, do that. So somebody somewhere has to have added those hooks into the application to make sure that your automated script can connect and pass information back and forth. And there's a ton of different ways to do this depending on your application. But once you've got that, this logic remains the same for whatever type of app you're using. So we're going to take in the test logic that we had before. We're also going to take in all of the permutations, and we're going to put those together with an understanding of how those map to the actual application, in our case, the game. And that's going to help us create all of the test automation sets. So we're going to hit a button, and we're going to have a number of test steps coming out in automation that can be run against the game. So as I mentioned earlier, execute and report are fairly self-explanatory. Run the tests, get the outputs, collect the data, create the reports. So I won't dig too much into those. It's important to recognize that each of these stages should be standalone components. So if we build this way, if we architect correctly, each node can be changed or modified fairly independently, and they pass things off between each other. So input creates the inputs for the generate stage. Generate creates the scripts that are used to execute. Execute obviously does the work that we're reporting on. So everything leads to something else. Okay, that's a lot to take in on a single slide. We will go into a couple more details shortly. But before I do, are there any questions about sort of test automation frameworks in general, or the way that I've sort of outlined them here? I will pause for a drink. All right, so let's jump ahead then and get to sort of the fun stuff. And I want to talk about how we're using the data-driven test automation flow at Ubisoft. So this is a general representation of the flow. It's going to get complicated. So follow through with the animations here so you can sort of see what happens to get a full picture for how it works. So at the input side, we've grabbed the data and the test logic. With that information, we know that we have to go to the game itself and ask for information about the game. We could be doing that by going to the engine or to a running game system, getting it generated out of the build pipeline. So however we're doing that, we need to get that data. From that, we go and create that test conditions file that I was talking about. Our generate step grabs the test logic, it grabs the test conditions, churns them all around, and outputs the test scripts. So now we've got actual automation scripts that will be run against the game. At the execute side, we're going to take those test scripts and we're going to run them. In our case, we've got test farms for each of our major games. So we'll use them, run the scripts against the game test farm, and that will already create an execution report. So we'll see exactly what every single test did as part of the execution report from that farm. At the report side, we're going to have a central data store. And at that point, we're going to take in information about what happened in input, what happened in generate, and what happened in execute, gather those all together. And we're going to create automated test reports from those and from information about the actual run. So this is how we're doing the work. And this is how, for all of our test cases, we formatted things. But I want to go to a specific case now. Excuse me. So in Assassin's Creed Valhalla, we've got this concept of opals. So they're a feature. So for this feature, we've got this secondary currency type of opals that are either found in the world just sort of laying around, or earned as part of the game play, right? You got to think of them like the Bitcoin of the Assassination Underground, right? Run by this criminal mastermind with the codename Rita. Silly joke. Okay, the manual functional test for opals is pretty straightforward. Go to where the opal is, pick it up, put it in your bag, right? Check that it's in your bag, of course. I'm hand waving a little bit here since there are other things that the manual test team does while they're doing this flow, but functionally, this is the thing that they have to do. Go and make sure that we can pick up and interact with opals, and that when we do, they go into our bag. Obviously now, when they've got a whole bunch of opals, they try and buy things. Sorry, that's some motorcycle outside my room. As simple as this test flow is, though, there are some significant challenges for the manual testing. At launch, there was 400-ish opals, I think 402. By the second season downloadable content, which First season is just being released in the next couple of days, I think. The second season will go up in a few months. But there's 719 inside the game build today. And that is surprising because that's obviously a fairly large jump. In addition, opals were added, moved, and removed without warning. And this is something that we've seen as we've been doing this work. I was telling Mike just before everybody joined in that in between the time that I ran the data flow that I'll show you in a little bit, and when I ran it just a few minutes before the start of the presentation, another opal had been added to the game. So it is 719, I changed it here. It was 718 just a little while ago, like a couple of hours ago. I guarantee you nobody sent test a message to say, hey, we added another opal. You should go and test that. Right? Of course, there are more downloadable content drops to come, and we know that that's going to raise the number even higher. So in addition to the challenges with the overall development flow, I don't think anybody is surprised to hear that development doesn't necessarily just tell us everything that's happening and that all the changes are coming when they come. And it's not just that they added one today. We regularly see that opals get moved. And part of the game creation allows the designers to go in as they're working in a world area. And if they see that something, oh, you know, that's slightly in the wrong position, I'm just going to move it. They just do that. But they may not go and tell everybody, hey, I moved this opal in this location by 30 centimeters to that location. So the communication doesn't always happen. So there are a couple of key questions that come out of this. Is it reasonable to expect that manual test can keep up with change and regression at that level? And what we're really asking is, will manual tests run all of the permutations? 719 opals in the game today. And are they going to run those all every single build? We get on average 3 builds a day. At times we get more, at times we get less, but you can pretty well count on 3 builds a day. It takes a long time to go do this test manually. It takes a long time to go do it with automation, actually. Doing this on every platform for every build is simply not feasible. So this is the same picture from before, but now I'm going to put in the specifics of how we deal with it for the actual opals. So the same thing, we've got the test file, we've got the data that we need to get and the definition. In this case, we've built in a module to say read Anvil. So Anvil is the engine used on Assassin's Creed VALHALLA. So we put in a module to tell the input flow how to talk to the Anvil engine. We also, for this particular case, we were outputting the file to a CSV that I'll show you in a little bit. So we had to put in a module here to tell it to write to CSV. One of our other projects, the POC, had them do it in JSON instead. And we actually are also starting to write all of the information straight into an Elasticsearch instance. So these are all individual modules that sit into input and make it more flexible for additional test cases. And that's part of the test automation framework component that we were talking about earlier. It can't be just for one test. It has to be something that can be utilized across multiple tests. So we write the CSV. So now we've got the CSV of test conditions. We read the CSV. That was obviously a module. And the test automation tool that we use on VALHALLA for this type of testing is called dtest. It's an internally built tool by one of the guys. Super cool. But effectively, for our purposes here, it's how we interact with the system and talk to the game and to the engine from the automation scripts. So it provides those hooks that are necessary. So we're writing our test scripts inside dtest or in a dtest format so that we can run them. So we then run them, of course. We pop up dtest, we run them. We've got our own dtest farm. Dtest also does all the orchestration there. And we get this dtest farm execution report. Now, since we knew that we wanted to start grabbing information from Elasticsearch and get some real trend information in reports, we started doing that at the input stage. This is something we've already done. So we're writing to Elastic stage as we do the input, or to Elasticsearch, sorry, as we do the input stage. That's giving us some input report data. We're putting them into a shared Elasticsearch instance. And we're creating data trend reports out of that. And I'll talk about those in a little bit because that's been a particularly interesting sort of side benefit. We weren't expecting as much value from as we're getting. So there is more to come on this. This is something that we are in active development on right now. The game has been successful. It will continue to run and stay live for a while. So we're making sure that the automation we have for it will support the continued development. So there are things that we're doing here still. We're going to take information about the generate flow or stage and put that up as well into the shared Elasticsearch and the execute stage. We know that in our case, we have to grab information straight off the D-test farm that we haven't done yet. So we're currently working on a module to do that and then put the data back up into Elasticsearch. And from there, we'll generate all of our actual automation reports. So more to come with that. We are in active development on this as we speak. So I want to jump a little bit, and I know there's a lot of data there, but I want to jump a little bit into the input stage. And I won't go too deep into the details, but let's take a look at what it means when I say we're going to go get the data, because that's what this is about, right? This is about getting data from the game and putting it into a format that can be used to generate test automation, or automated tests, sorry. So we've got some inputs, right? We know the test is the ACK OPALS test. ACK was the code name for the game before it released, and I can't stop calling it that, I apologize. And the source for our data is the Anvil engine. So there are actually 4 stages to the input stage. And yes, that does mean that those are the stage inputs to the input stage stages. Naming conventions are fun. So anyway, there are these 4 steps. We have a tool of our own, another in-house tool called T-Box that allows us to automate process flows. So we're using that here to create not the automated testing, but the automation of the work that we have to do the automated testing, if that makes sense. So the first thing we do is get the package info. So we have to know what builds have come out. So no big deal. We've got a process in here, a macro. It goes up and it finds all new builds that have come out for the game. From there, we have to take the data change list out of the build number, and we have to synchronize the engine to that data CL, because now we've got the actual data that will be in that game build. From there, we go talk to the engine. We've got a process. This is a ridiculous hash. Oh, sorry. A ridiculous hash that allows us to talk directly to the Anvil engine and run the script that will generate the data for us. And then we output this into the CSV file. I'll show you what that looks like here. So if you take a look in the last couple of days, these are all the builds we've had. So you'll see the build version number plus the data CL, because that was the important thing for us to write out. And this is what that looks like. So this is the information that we determined was necessary for each test permutation. So each one of these lines indicates a unique test somewhere in the world. So go to this location in this world, which is part of this downloadable content, and you will find this opal. And all the opals have somewhat unique worlds, right? So this is the data that we will use in order to generate the automated tests as we go forward. So let's talk a little bit about how we actually do that generation. So we know the goal here, right? The goal is for us to take that data file that I just showed you, the CSV, and create the automated test scripts themselves, right? So we still need the logic, so we need to know what the test is, because that's what's going to tell us how to sort of construct the automation. And we need to understand the sort of data that leads to it, so all those test conditions. Unsurprisingly, there are 4 stages here as well. And sure enough, we also use the T-Box macro or the T-Box tool to automate this part of the flow. Let's look at those steps. So the first thing we have to do is read that test conditions file. So we go get it, we read it, and we identify, in addition, all the test steps. So the automation test steps are a little bit different from the manual test steps. we have to load the right world. We've got to go to the location. We've got to look around to see, is the opal there? We take a picture of it. Figure that's important. We interact with it, and interacting with it is in the game, you interact with it and that acquires it for you. And then we check that it's inside of our inventory. Based on the test steps and reading the test conditions file, we start pulling the data out of those the test conditions file so that we can actually do those tests. So I need to know the world to go to, so I'm grabbing that. I need to know the object ID that I'll be looking for, and I need to know where in the world it physically is. So these are all data points that I need, and there are a few other ones here. I just wanted to hit the highlights. After that, we actually go and then just generate the test files themselves. And that's kind of a neat state. So if I take a look, just delete these two files, we can show you what that looks like. So I went and pulled the core part of the script that generates this automation just so I could sort of show it to you. As I run it, it's done. So we just ran and processed 720 entities, 719 earlier. From that, I generated the actual test files that we will use in the game so that we can do all the runs. Right, so if I take a look, this is the specific test file that will say to go use the test file that will be created for this. Each one of them has its own case. And then the data, oh, sorry, the wrong one. And then the data for that specific file itself. So this is everything that goes into it. And this actually then gets run by our detest system and the automation runs. And what winds up happening, and I couldn't grab a video for this, unfortunately, that didn't get through our sort of checkers, but we teleport into the world, we load the world, teleport into it, go to the location, wait a few seconds because objects only spawn when you come close to them. Once we've waited an acceptable amount of time, we search for the item, make sure that it's physically in our proximity. If not, we move towards it. We then interact with it, make sure it gets into our inventory and check that our inventory has gone up. And as I mentioned, we've also started taking a picture of it because we identified an opportunity to grab pictures so that during failed states, we could send that information up to the development team to show them what we saw as we were attempting to interact. So that's it. And that's how fast that happens. I mean, you saw that that's the case of a couple seconds, sorry, is all that took to go and generate all of those tests. So the automated process in generating the tests themselves is incredibly quick. So there's a couple other little things that I wanted to talk about with the generate stage, right? There are things that we do here that help us work with the automation more effectively inside the game. And the reality is that we don't always want to generate all of the tests. And there's a lot of reasons for that. And if you're just starting out in automated testing, you probably can't imagine having so many automated tests that you can't run them all. I mean, that just doesn't even make sense to some people. But believe me, it happens. And it happens a lot faster when you're using automation to create your automation. Because now you don't have to manually go in and write 719 cases. Or if 3 opals move, go and edit 3 of those before you can run the tests, or add a new one because development just added 1, or take away 3 because development took out 3. So when you're using automation to create your automation, you can very quickly get to a point where you have too much automation to actually be able to run every single build, even every single night. So there's a couple ways that we restrict the size or the number of tests that we generate. The first one is by batch size. And again, there's a couple of reasons that we do this. Depending on the number of machines that we have available to run automation on, in a small farm, it could be 5 or 6. Could be like 3 PlayStations, 2 Xboxes, and a PC. It could be 50, depending on the farm that we're using. So we will adjust the batch size so that we can take the most advantage of the farm that we have. The other thing that we do, and it's because of weirdness. So if you think about the way that automation does this, it loads the world, goes into the world, teleports around, interacts with the world, and then does what? Well, it teleports to the next location, next location, next location. Here's what we found. If we do that a few hundred times in a row, weird things happen. It's because this isn't actually a real game flow. People can't do this while they're playing the game, and the game developers never really took that into account, I suppose. So when we just teleport all over the world like this, without doing proper game reloads, things go sideways. So we have found that it's better, depending on the speed of the machines that we're running on, to limit the number of test cases that we put into a single flow before we reboot the game as part of it. We don't want to reboot the game every time because it actually drastically increases the amount of time it takes to run the automation. So we might also want to restrict, and we do often want to restrict the number of test cases we create to a specific world or downloadable content. So the release that's coming up in the next day or so, I think, maybe it released already, is the Ireland downloadable content. Very much in the last few weeks, we only ran those OPALs, and we ran the OPALs for that far more often. We ran everything else as well, but we ran it in the background at a lower frequency. But the new area, new content, we ran far more often and far more extensively, actually. There's also some situations where we just don't want to run them all anyway. So even if we're only working in the Ireland downloadable content, we might want to restrict it to 10 or 10% of all the ones in that particular DLC. That includes some level of restrictions. So give me 10% of all the cases in the main game release flow. The reason for doing that, and there are of course a number of them, but it all comes down to time. The 719 OPALS test cases, if we have 3 machines and we batch at 15 tests per reboot, it takes 90 minutes to run those tests. We run the tests on PlayStation 4, 5, Xbox One and X, PC, Stadia. So we run a lot of tests. We have a lot of platforms that we have to release the game on. And it takes us 90 minutes on 3 machines of one platform type. There is simply no way that we could do every test for every build on every platform. So we do a bit of randomization here. You know, we're going to grab 10 for every build, 10 per world per build. Every night we'll grab 100. Every weekend we'll grab them all. We might batch them up so that some are running on one platform and some other ones are running on another one, but we randomize it so that we get good coverage across all platforms. So I thought it was worth just talking about that a little bit to show that we have to be, and we've had to build in the ability to be, you know, to sort of follow along with what's necessary in the test flow. So execute and report, again, I'm not going to go into a ton of details on these. There are just a couple of little things that I wanted to call out though. On execute, the big thing for us is platforms. So I just, you know, I told you already that we've got enough platforms to run that we have to run all of the OPALs against all of the platforms as often as we can, or do we, and how do we do that? So the execution and the platform execution was actually quite an interesting problem for us to handle, particularly since the platforms themselves are slightly different. So the automation has to be built in such a way that it will work across all of them. We also have to figure out what to do with failures. Things happen. There are a couple of OPALs we found right away, actually, that were just broken. Great, we found those. But there were some that only broke sometimes, and a couple that only broke on certain platforms and not on other ones. So we had to come up with a plan and a way in our execution system to determine what to do with the failure. Now, as it turns out, we do rerun every failure. So if something fails, we run it again. And we're getting to the point now where if it fails on a PlayStation, we definitely run the same test on an Xbox and a PC to see if we get the same type of result. So that's actually been quite interesting for us. On the report side, the one that I wanted to call out here is the input trend data. mostly because we finished that case already. But we found some really interesting stuff here. One, I mean, obviously it's nice to know when we can see that Dev has added a new opal without telling us. That's been fantastic. But knowing when the opals are moved or removed is also very useful. The best thing that came out of this for us is that we were able to generate a report for every single build and send it to the manual test team and say, hey, you should go look at this. Go to these locations and look at these opals because they moved. These opals changed in some way, or these are the brand new opals, you should manually go test those. So in addition to being able to focus our automated tests and sort of do what we're doing, we're also able to provide value to the manual test teams and give them almost like a hit list of things to go look at. And sure enough, they find bugs. So even when the opal works for us, like functionally it works, I can get to the location, I can take the picture, I can interact with the opal, and I can make sure that it got to my bag. Fantastic. But when we are able to help the manual testers focus their manual time, and they go into areas where there's been change, they find all the other bugs, right? The things that manual testers are really good at, you know, does it look right? Does it feel right? We can't do that as easily with automation, but we can absolutely help identify places the manual test is more likely to find things to actually care about. So that's been a super interesting thing that's come out of sort of that trend data analysis. And if you think about it, we're providing value with the automation process before we even do the test. And that's been, again, super, super interesting for us. So inside Assassin's Creed, it isn't just the opals. And that brings us up to some of the other test cases that we're working on. Opals was our first one. We thought that it was, you know, fairly simple and straightforward, and there was a ton of them coming into the game, so we wanted to do it. Since I've added this slide a couple of weeks ago, by the way, we've added a bunch of other ones, but these are the ones that 2 weeks ago we were working on and working our way through. A good chunk of these are now finished. A couple more, the last couple are still in progress. So loot boxes, this was a great extension of the opals test. Go to the location, interact with the object, confirm that you get the stuff in your inventory. The big challenge here is that there's over 1,400 of them, and they're growing a lot, and they have different contents. So it's not like I can just check, did my opal count go up by 1? I actually have to know what was supposed to be in the box, what I actually got out of the box, and then what I really get in my inventory, because they're not always the same thing, surprisingly. Bugs are fun. The other really interesting test case that we did recently is the books of knowledge. So inside the game, as you're playing, you can find these books of knowledge that give you special skills. And these were an interesting test case for us. So there's only so many of them, but they're adding new ones in the new expansions. So I put N there because, to be honest, I don't even remember how many are actually in the game because it changed in the new DLC that we were testing the other day. But when you interact with them, you not only get an XP reward, you also get a special skill reward. And that isn't something that I can check in my inventory. I actually have to check my player stats. And I have to confirm that not only did I gain the new skill, but the skill is available for me to interact with and add to my list of skills that my character can use. So that was quite interesting and provided a different test for us to have to deal with. The Lost Rengar are quite an interesting test case. These are sort of mini world boss fights. So there's only a certain number of them. But the sort of interesting test case here for us is that we had to figure out how to handle dialogue. Because before you get into these fights, you have to talk with them and interact with them and follow the flow so that you start the fight. And that was quite interesting because we had to figure out how to draw our test definition files in a way where we could handle that case. So no more of those will be added, thankfully, because that was a problem to deal with. For those, when we kill them, we get fight loot and XP rewards. We just had to validate those. The legendary animals they were super interesting. Again, they're bosses, very similar to the Lost Rengar. But in this particular case, when you kill these legendary animals, you get a trophy that you can take back to your settlement and actually mount, and then it shows up in your settlement loghouse. So there's quite an extension capability to this one. The first part is the same thing. There's a certain number of animals. They're adding more into the new expansion. Go to the location, interact with them, kill the animal, make sure that you've got the loot. But we're actually now starting to work on the next part of that script, which is if I have that trophy, can I bring it back to my settlement, interact with the hunter who is supposed to mount it for me, and then confirm that it actually shows up in my longhouse. So we're getting another data-driven test out of the data-driven test, which has been super cool. So the last two that I'll bring up here were my favorites actually to work on because I thought they were kind of fun. And that was Excalibur and Thor's Hammer Mjolnir. For me, these were quite neat because one, they're cool. I liked playing in the art, but both of them had really interesting challenges in the test definition. So with Excalibur in the game, in order to get it, you have to find these 11 special tablets around the world, around sort of the world, which in our case is England in this case, for that part of the game. 8 of those are collectibles, so you've got to go into super secret dungeon areas, parkour all through them, get to the chest, open the chest, and get the collectible. For the other 3, you have to find a zealot, a world boss, fight with them and win, and they're hard boss fights. The hardest part about that was actually finding them, because these zealots don't just stay in one place. They can move through an entire cycle, so we had to figure out where they were before we could teleport the character to them so that they could interact with that person. So that was quite neat. And then as part of the test process for this, we had to grab video of the special cinematics, because there's cinematics around both Mjolnir and Excalibur that they wanted to be able to validate. So we had to sort of record the video of that, save it out so that manual tests could verify it later. And then of course their unique loot that has special circumstances once you get them into your game inventory. But both of them were very interesting, both in terms of how we generate the test data and the test definition, but also getting the different types of data from the game, because both of them required us to get completely different sets of data. With the opals, it was pretty easy. Find an opal, get the ID, get the location. But these all had many, many steps of data. And the data acquisition out of the engine actually became quite complicated. So we found some general benefits to this approach, and I want to hit them here quickly before I get into sort of the deeper ones, and then we'll be done and go into some questions. What we found is that a lot of our games have features that can be tested this way. As we were doing the POC, we very quickly identified a dozen more cases in Assassin's Creed alone. We've got 2 unreleased and unannounced games I can't tell you anything about that we're also doing proof of concepts with on these, both of them on different engines in Assassin's Creed. So that's been an interesting challenge. I've had other game teams now come to our department and say, hey, can we get it? Can you add it for us? And can you do it for this type of data as well? So that's been super cool. We're testing at multiple levels. So not only are we going into the running game and doing the manual functional test, but we're now testing the data itself. So as we do the data ingestion, we're looking for data that's bad, data that isn't formatted correctly, and flagging that and sending it back to dev. The first time we did that, by the way, the developer said, no, that's not right. You can't test that way. I don't believe you. Prove that it doesn't work in the game and then tell me it's bad data. So we did. And then he looked at the data and said, well, of course this can't work. Look, the data's wrong. But he wasn't used to somebody telling him about a defect like that and to be that specific. He couldn't quite conceptualize it. We're also seeing that we're getting additional data for decision making. So the people who are making decisions about the game and shipping are now getting more data, and data that helps them understand churn and what's going on in the dev world. So that's been super cool. There are some specific benefits, and I'm going to hand wave over this a little bit because I realized that I talked too much. But we have identified specific benefits, figured out how they're benefiting people, and who is really benefiting. And that gave us the list of people that we needed to go pitch the idea to. to get them to say, yeah, you should put a team on this for my project. And that has been really interesting, because by identifying the people who would benefit and how they will benefit, we were able to get right to the people who can make the decisions to put the team onto it and get things done. There were a couple of interesting unintended ramifications of what we did. It shouldn't be a surprise to anybody that data consistency matters, right? On a project like Assassin's Creed, you probably expect there's a lot of developers. You're right, there are probably more than you think. And in far more countries and Ubisoft studios than you'd expect. I believe the count was 16 studios across 14 countries. And the development team size is less than 1,000, but more than 700. I'd have to double check into it. Like it's huge. So yeah, not all the data was entered consistently using the same naming conventions or parameters. If you take a look at the data file that we pulled just for the OPALS, you can see the inconsistency in file naming. They weren't even close. And there's some of them, okay, yeah, you can see parameters, then it's like, what the heck is that? Like, how is this a similar convention to that? And it really identified for us problems when we were looking at the data itself. And that gave us an opportunity to identify ways that data generation itself can improve. That first time that we went back to the developer and said, hey, your data's bored, his answer, by the way, at the end was, well, I wasn't finished. I wasn't done. So why were you checking my thing? Cool. But that actually has given us now something that we can do inside the engine so that a developer can flag something as partial. And they have to actually set the layer differently now so that OPAL is now available for us. And that's something that's going to change the way that data is entered into our games going forward. Once I get it to all the teams, we've got one team on it so far. And both of those things are really baby steps along the road towards quality engineering. And this is something I could soapbox on for an hour, so I will quickly shut up about this. But it's fantastic that I can now start to get development teams to understand why they should do it right, rather than just do it, and then we'll test to find out if it's right. And that is the core of quality engineering. We're changing the way that development works, and that's just fantastic. So why were we here? Did we get out of the presentation what we wanted to? And I will ask you in a minute, and I hope we did. But from my perspective, I do hope now that everybody sort of has a general understanding of both the data-driven test automation approach or test approach and the concept of a test automation framework. I showed absolutely how we're using this at Ubisoft today on Assassin's Creed VALHALLA and some of the cases that we're working through next. And of course, we do have these two other games that are already doing proof of concepts that are quite interesting. And we did talk briefly about some of the benefits and unanticipated side effects that have come out of it. But that's it. That's the whole presentation. And it only took 12 minutes longer than it did the first time I gave it. So questions, thoughts?
Does anybody have any questions for Sean?
Thank you, Sean. It's awesome. Thank you for sharing all this. It's all so great summed up and like so systematic. I have some questions. This is Olga. Just for my understanding, are we talking about, when we say about automation tests to verify the behavior of the objects, are we talking about unit and integration dev tests, or it's API, or it's a front-end automation?
So that's actually a really good question. The tests that I'm talking about here are actually interacting with the game as a player would interact. So the only thing we're doing that a player wouldn't do is we're teleporting to the location rather than walking there. That was a necessary thing for us to do. So we wanted to get as close down into the development cycle as we could, pull the data up, and then run the tests, not at the unit level, but run them in the actual game itself. And that was sort of where we got to marry the under the covers data approach with the end user test approach.
Thank you. And could you please recommend the tooling that you prefer and pros and cons you see for using those? Looks like it's a thick client, right? You have the native app. So
in this particular case, and because of the way that we have to interact with the engine, we have to have very specific tools to allow us to do that. But realistically, any system that allows you to interact with the application you're working on, most of my career was in mainstream software. So I've tested everything from thin and thick clients, to web clients, to mobile apps. Any tool that you have that allows you to interact with the software that you're doing automation for gives you the same thing. You just have to have in your test definition file the thing that allows you to take the parameters, the variables, and say, make my test look like this. So whether you're using a Selenium backend, for a web client, or a REDUX, it doesn't really matter. At that point, all it is generating those automated tests from the data that you have from the system.
It's great. Using automation to generate the automation, that's great.
Absolutely, and that's where people get freaked out and think we're starting to do AIs, but it's not, because it's copy and paste code almost effectively.
It's parameterizing, right?
Yeah, exactly. Yeah.
And the last question, thank you so much. You mentioned screenshotting, so it also doesn't matter. It's just a part of the framework that you use to connect with app. So there are many tools for screenshotting of the failures, right? So nothing.
Yeah. So we're doing it inside the game, and it started on OPALS with us taking the screenshot because where it came is when somebody had moved in OPAL, but we were still able to interact with it in a new location. We wanted to grab a screenshot and then send that to manual test so that they could do a quick check. Hey, we noticed that these 5 OPALs moved. Can you just do a quick verification? Here's a screenshot. But when we got to like Mjolnir, Thor's hammer, and Excalibur, now we needed to record video. So we needed to record the actual video of the cinematics effect that was happening as well, and drop that into a folder for manual test. And the side benefit to that, really, and it's something that we've been doing for the past little bit on other tests, is there are times when we can't use automation to do verification because we can't tell if something's right or wrong with automation. It's not binary. Does this look good? Isn't something that automation is good at doing. It can do it, but it's not great at it yet. But I can make it a lot faster for a manual tester to answer that question. Instead of making it so that they have to go running through the world to get all this information, I can go get it for them and put it into a video to allow them to sort of see what's happening. I could do a completely different presentation on some really cool things we've done on the latest Far Cry, specifically around clothes and textures to make sure that the clothes and textures are working correctly and the different things that the characters can do. And we aren't using automation at all to do any feature verification. We're using it to make the manual testers' lives so much easier. So yeah, that screenshotting and video capture has been super beneficial.
Yeah, to pinpoint the area.
Yeah.
Thank you so much.
Happily.
Does anybody else have any questions for Sean?
Yeah, I had one. This is Nicholas. Thanks for the presentation. First of all, it's really, really interesting. I was wondering if you could elaborate a little more on the generation part. How do you actually go and build those tests from the data? Is it building blocks of pre-written code or what?
Yeah, so what we actually use is a template file, and I can't show that. I can't show that because it talks a little bit about what happens in the back end a bit too much. But the template file itself, all it does, it's doing a Gherkin transformation here. So the other thing I didn't tell anybody about this, the way that we wrote the test automation system, DTest, allows non-programmers to write automated tests. So they can use Gherkin to create a test statement. So given this condition, when that happens, then verify this, right? So the given when then is actually a way that we can write all of this test automation. So I know what that template looks like for the OPALS test and for all these other ones. So we've written that sort of template, And now we've just parameterized all the variables. And what you see on the screen here, the world, the object ID, and the position, for the OPALS test, those are the parameters that I need, in addition to a couple other things like where to put the files and things like that as I output. So what happens, and honestly, that was what I generated just through that little quick Python script. Wrong one. Sorry, through the Python script. Yeah, there it is. What it did is just go and run and create the scripts. And where is it? Yeah, they're there. And generate this actual data file itself. Yeah, that's it. So the test automation system with that template file in the background takes this variable. So for this particular test, right, for in calling OPAL1, blah, 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 it swaps out these variables and then runs it and just goes through it. So one after the other, boom, 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 boom. And it's entirely done exactly as just with a template file in the background. And we swap the variables that Olga was asking about earlier. It's funny, Nicholas, when I saw your name, my boss's name is Nicolas Martin from Paris. And my first thought, because your picture hadn't come up, is what the hell is he doing? It's 4 o'clock in the morning in Paris. For a second. So that's good.
My name is pretty common, especially in France.
Right.
Yeah, thank you. I had another question. I forgot it. I'll come back.
No problem at all. The fun thing is, I mean, I'm doing this in a game now, but this is, you can do this on anything, right? I mean, when I think about the very first application I worked on as a manual tester, it's a financial treasury app, and I wound up creating a FinCAD for Excel data file in the back end to do almost exactly this thing. And that was in 1998, right? I mean, so the technique has been out for an incredibly long time. And yeah, I'm using some automation now to do this a heck of a lot more seamlessly. And the way that I'm interacting with games is very, very different than anything I did in financial treasury, but it's the same flow. Like it's the same approach to generating it. And it's just super powerful how far we can go with it now.
Great. Any final questions? Nicholas, did you?
Yeah, I remembered what it was.
Sure. Go ahead.
I was just wondering if you had experience previously for data-driven testing where you don't generate your data every time. You know, is it still successful to run it through if you define or have preset data inputs?
It can be. The challenge, and as a matter of fact, one of the other games, so the first or the next or the most recently released Far Cry game, we didn't have the ability to go get the data automatically. So we just got to the point where we could generate the test cases automatically using the same flow, but we manually wrote the data. And that's been great, right up until development changes something. And it's your appetite for change that becomes the problem. Now, when they did it, they were very close to their launch, so that was not a big issue. There wasn't a lot of things changing. But in the first couple of game patches, they made a bunch of changes and had to go back and manually reset the data. Now, it wasn't as bad as it could have been. They didn't have to go rewrite the automated tests, but they did have to go back and tweak all the data in the underlying file so that they can regenerate them. And that was a challenge for sure, because it was harder for them to go and fix it. So you can see how it starts to fall apart quite quickly, and you don't get that trend data. You don't get that information about change over time that's been really valuable at sort of showing the team churn. And one of the test leaders on the project came to me and said, "Man, seriously, development is adding 4 or 5 opals a day right now? What the heck? We're supposed to be launching the game in a week, right? Like, how is this happening?" And they were reading from the wrong branch, so it wasn't a big deal. But, you know, just they didn't know that they could get that data. They didn't know that that even existed to find out the information about change in a game over time. And as we're doing this for more areas than just opals, we're starting to get a better picture for what code freeze means to a dev team. not always the same thing. So it's been really neat. I would recommend where you can to generate the data automatically if that's possible. But even if you can't, do the test case generation, the automated script generation through the data. It'll save your efforts so much.
Great, thank you. A lot to think about for my own project now.
Oh yeah, well, how do I take this home now, right? Yeah, I know, that's a hard question.
Well, everyone, it is 7 o'clock. Thank you so much for joining us tonight. As always, VanQ Meetup is presented by Optimus Information. We have recorded this session, so we will be posting that on our social media in the coming days. So if you'd like to circle back and kind of go through things again, you're more than welcome. Our next event is Thursday, May 27th. Speaker to be determined, to be announced, and we'll keep you posted. Thanks, everybody. Stay safe, stay healthy, and be well. Thanks, everyone. Have a good night.
Guys, feel free to reach out to me on LinkedIn if you have any questions or you want to start playing with this for yourself. Feel free.
Awesome. Thanks so much, Sean.
Thank you very much, guys.
Really appreciate it.
Oh, happily. This was fun. Have a good one, guys.
Awesome. Take care, everybody.